Right. So the last question. Okay, a car runs at a constant speed. Let me do a quick revision. Constant speed is like this. Acceleration is like this. Deceleration is like this. Okay. So we're going to just be playing with three lines. This, and this. So let's start. A car runs at a constant speed of 15 meters per second. This is my velocity, this is my time. This is called a velocity time graph. So at 15 meters, let me mark this point as 15 meters per second. Actually, the unit is there, so there's no need to write it again. Okay, sorry. 15 meters per second at a constant speed. Will it be this or this or this? This. For what? 300 seconds. So I'm going to draw a straight line like this for 300 seconds. I'll trace it. Seconds. Can I continue? Yes. And then accelerate uniformly to a speed of 25 meters per second. Accelerate. This or this or this. This. Accelerate. It's going up. Accelerate. Keeps going up. To a point of what? 25 meters per second. So let me assume this place. This graph is not to standard. It's not drawn to standard. Okay? So this is 25 meters per second. Over a period of what? 20 seconds. So this point down here, 20. Will I write 20 here? No. I will write 300 plus 20. 320. Let me put time here in seconds. So everything here, you know that it is in seconds. Okay, let's continue. Over a period of 20 seconds, right? First off, this speed is maintained. It's the same thing. Maintained, constant. So we're going to be drawing this. This speed is maintained for 300 seconds. So it is maintained. It is maintained for 300 seconds. So it will 320 plus 300. 620 seconds. Okay? Before the car is brought to rest. What is the meaning of brought to rest? Final velocity is what? 0. Final velocity is 0 before it is brought to rest. So I'm going to do this. The time is what? 30 seconds. 620 plus 30. 650 seconds. So this is the diagram. So this is the diagram. And then we are expected to draw the velocity time graph. We've done that to represent the journey described above. Now, from the graph, we are asked to find this question. They are not asking you to calculate using the logs. We are to calculate using the graph. Alright. The acceleration why the velocity changes from 15 meters per second to 25 meters per second. For clarity, let me label each point. So this is M, I, V, A, Y. That's maybe. Okay. So I'm going to type to this one as C, E, P. Okay. Now, we are asked to calculate the acceleration while the velocity changes from 15 meter per second to 25 meter per second. So we are asked to calculate this acceleration. How do you calculate acceleration? From the graph. From the graph. The acceleration is change in velocity. Change in velocity over change in time. Change in velocity over change in time. So we'll be having V2 minus V1 over C2 minus C1. This is how to calculate the acceleration. It's the same way of calculating a slope. Okay? So V2 is this point here. And okay, let me use this. Okay, so V2 is at this point here, V1 at V, alright, minus V2 is at this point I over, how do you calculate T2? Now at the point of V, we have a value at the second, which is what? 320. So that point is E minus, let us trace I is traced to P. Alright, P. Alright, so V is 25 minus I is 15 over 320 minus 300. So this will give me 10 over 20. And this will give me 0.5 meter per second squared. So this is how to calculate the acceleration while it changes from this point to this point. Now, we want to go to question 2. The total distance covered in this time described. Now, I want you to pay attention to this. You can pause, go back and copy that. I need enough space. Okay, now to calculate this, to calculate the distance, I want you to pay attention. Calculating the distance is looking at the shape. Once you find the area, you found the distance. Once you find the what area, you find the distance. Let's do a quick revision. What's the area of a square? Length times length. What's the area of a rectangle? Length times breadth. What is the area of a triangle? Half base times height. What is the area of a trapezium? 1 over 2 open bracket, that is half a plus b close the bracket times height. So we will be using this. There is no other shape that can come in our velocity graph, time graph. We can have a square. We can have a rectangle, we can have a triangle, we can have a trapezium. So let's go to this. I'm going to call this I. I'll call this I. I'll call this I call this IV. So we're finding the area of IV, and then once we've done everything, we'll add the answer together. So let's go area of I. Let's look at I. What does it look like? This point is 0. From this point, 0 to M is 15. 0 to P is 300. So this is obviously a rectangle. Obviously a rectangle. So I'm going to say length times breadth. So what is my length? My length 15 times 300. This and this is 4500 meter. It's as simple as that. I'll go to 2 area of 2. What shape is this? I'm having a shape like this, like this, like this, like this. This is a trapezium. So that is 1 over 2 A plus B times height. 1 over 2. You might not decide to use a plus b. You can decide to use what is here. Okay, for some students that would prefer using this, a is pi. I call it IP plus our b is EV, right? EV, and our height is PE, all right? PE. Okay. All right, let's do this. From this point, from P to this is 15, all right? 15 plus EV from this point to this point is 25, all right? 25, and then our height is this PE, which is 20. Mind you, a trapezium can come like this. Now, the question is, many students find it difficult to know which is A, which is B. It's simple. You see this line. The trapezium is from a rectangle. A rectangle is length times breadth. So let me call this A times B. A times B. That is the area of the rectangle, right? But at this case, we're now having something. It is cut off here. So it means we are having two bread, A, and we have another one here. So we need to add the two of them together. Look at this. We have the two of them together. At this point, where is it? This is parallel to this. So this will be our A, this will be our B. The other side will be height. Do you understand? Okay. So that's not part of so this will give me 1 over 2. This is 40 and 20, right? So this and this 20, 400 meter. All right. Using that value, area of tree. Let's look at tree. What's tree? We have 25, and then we have 300. So this is a rectangle. All right. Length times breadth. Or you can decide to use VE times ET. It's the same thing. So this will give me 25 times, the difference is 300. So this will give me, this is 5, this is 6, this is 700 meter. And then the last one, area of IV. Area of IV. IV is a rectangle. So that is R base times R. So this is 1 over 2 times the base is 30 times the height is 25, and this is 15 and 25, 15, 25, 5, 2, 7, 5, sorry, that's 10, and that's 375, 375 meters. So now to calculate the total distance will be I plus II plus III plus IV equal 4,500 plus 400 plus 7,500 plus 375. Everything here is 5, 7, 5 and 5, 10, and then yes, 7, 1. This 7 and 4 is 11, and then 12. So now the total distance is 12,775 meters. All right. So the last question is the average speed covered. The average speed over the time described. So what is average speed? Average speed is calculating the average speed, which is the same thing as velocity, is the distance, now the total distance over total time. So that is 12,775 meters over total time is 650 seconds. So our answer is 19.65 meter per second. So this is how to calculate velocity time graph. Sometimes the graph can be like this. Most times it's like this. So what we have here is a rectangle, a triangle, a rectangle, a triangle, and then you have the total area of each of these. That's how we find the total distance. Thank you very much. Please like, share with a friend who do not understand velocity time graph, or even understand for better understanding, and also comment if you have any issue, you want clarity, anything,